Okay, this lesson is on hyperbolas, and hyperbolas are the next conic section that we're going to be talking about. And it looks like it's two separate graphs, but it's really not. On this picture, I have the dotted lines, which are asymptotes. They're not actually seen. Your graph is just approaching those and getting close to them as you go further out, but they don't actually cross them. The curved parts that you see here are the actual graph, and these can be left or right or up or down. So I want to go ahead and show you the equation for this, and it actually matters what comes first. Here, you'll notice this looks really similar to what we did with ellipses yesterday or in the previous lesson. The difference is that between the first and second pieces, there is now a minus. Okay? Now, the way you know whether it faces left and right or whether it's in this part up here and is up or down is by what comes first. Since the x piece comes first, and it's the x piece minus the y piece, then it is a left and right curve. If the y piece comes first, it will be an up and down curve, and we're going to draw one of those here in a second as well. I want to label again what this means. In my class, you will not find this in textbooks. Again, I like to keep the a value under x and the y value under b so that they always mean the same thing. In textbooks, they will switch them up. So for us, the center of your hyperbola is right here. So that is the center. And our a is the distance left and right of the center. So in this case, this length right here is a, or this length right here is a. Now, so if that is a, as we have known, what does b do? B, if you made a little box, if you went straight up from those a's, and you looked at these little points right here, and you made a little box, which we are going to do to help draw these things. B is the distance up and down. And although you may not understand that right now, it will make more sense as we are drawing these and I'm adding in information for you with actual numbers. We will also have focus points. Our focus points will be located inside of the curves. So I'm just going to draw some here now to represent that. You will again have two. And again, we're going to call the distance from the center to that focus point C. So you'll have that distance both ways, but we will get into that more in just a minute. Okay, now I want to talk about one that would be facing up or down. Obviously, this picture is not facing up or down, so the first thing I want you to do is not to write down these curves. I just needed to have a basis of what to go with. And our actual graph that I want to be talking about is one that would be curved facing up or down. Okay, so again, our center is this point here in the middle, as we talked about before. The reason that this graph would be curved facing up or down is because down here the y value is coming first, and it is a y value minus an x value. And again, in textbooks they will have switched these a's and b's, but in my class I keep a under x and b under y because for me I like it to be the same every time. So I'm going to start with the b. The b will be the distance from the center up. So this time we can meet that curve by counting up b. And down B. So B is still our distance up and down. Now, if I went from that point over to these dotted lines that are the asymptotes that I will talk about more, and made the box, that left and right distance is our A. And since our focus points are now inside of curves, the focus points for this graph would be here and here. But the main thing to get from this is if the y is minus the x, the curves are facing up and down. If the x is minus the y, they're facing left or right. If you are having difficulty understanding what I'm talking about, hang in there until we do a couple of examples with actual numbers so that you can see what we're doing, and hopefully it will all make sense then, and you'll be able to relate a lot of this to what we did with ellipses. Before we go on, we want to talk about how we're going to find the focus points this time. Notice there's a change in this equation. Instead of doing big minus small like we did with ellipses, this is big plus small. So you're just going to add those two numbers. It should be very reminiscent of the Pythagorean theorem. The way that I keep these two straight is the hyperbola equation has a minus in it, like the standard form of the hyperbola equation has a minus, and the focus point equation has a plus. And it's the opposite. The ellipse equation has the plus in the standard form and the minus in the focus equation. So it's always an opposite sign there. The asymptotes, because I said, you know, you're going left and right A or up and down B, your asymptotes have this slope that is positive and negative B over A. So the one that is going uphill, would be a positive slope of B over A. The one that is going downhill would be a negative B over A slope. And we will be drawing those in to our actual examples. Okay, so now we're to an example, and this one is coming to us in standard form. We have y minus 1 squared over 9 minus x minus 2 squared over 4. And we're equal to 1. Again, in standard form, we should always equal 1. And we know it's a hyperbola because of the minus between it. A couple of things before I write down my A, B, and C. I want to go ahead and locate the center. And we will locate it the same way that we located for ellipses, except you have to pay attention to where the x's and y's are. So the x value comes from the piece with the x, and the y value comes from the piece with the y. You can't just do which one comes first and which one comes second. So the x value will be a positive 2, and the y value will be a positive 1 for our center. Also, before I do other things, I want to notice which one comes first. Because the y comes first and it is the y minus the x, I know that these curves are going to be not left and right. These curves are going to be up and down because it is the y minus the x. So I can make myself a little note that I'm going to do this sort of shape when I get to the graph. Alright, so then I come up here and I find my A, B, and C. I look under x to find my A values. So the square root of 4 is 2. I look under y to get my B. The square root of 9 is 3. And then I know that C squared is big plus small. So in this case, it will be the 9 plus 4 will be 13. And then my C will equal the square root of 13, or about 3.6. So I'm going to go with 3.6 down here, officially. But if you were in a multiple choice situation, you might see that square root of 13. Okay, how do I draw this? Well, I locate the center, 2, 1, and plot that point. I want you to take your A and your B and do what you did with ellipses. So I'm going to go left and right 2, and up and down 3. Okay? Now, make a box out of those just dotted in, because it's not really there. It's just to guide us. Make a box using those points. Okay, now we're going to draw in our asymptotes, and those are just going to go diagonally through the corners and the center. So I have an asymptote that looks like this to the best of my ability. If you have a ruler and actual graph paper, it will probably look a lot nicer. So there are my asymptotes drawn in, just corner to corner and through the center. And I'm going to draw in my hyperbola. Now, we said this one is an up and down. It will actually touch the box on that point that was 3 above the center. So it will share that point with your box, and then you will just make your curve approach your asymptotes. And the same thing at the bottom. It will actually touch that point, and then you will curve toward your asymptotes. That red now is the actual hyperbola. The last thing to do is to put in your focus points, which would be 3.6 away from the center. And since we're curving up and down, I'm going to count up and down. So if I count up and down 3.6, it's very, very close in this case to the actual vertex, and mine disappear as always with this program, but you'll want to draw those in. Okay, as we move to example 2, you will notice that this one is not in standard form, and so a standard form will equal 1. We will need to divide by 16 so that it is equal to 1. I can reduce 4 over 16 to 1 over 4. So this becomes x squared over 4. There's nothing to reduce here, so I have y squared over 16. And then 16 over 16 is 1. I can notice immediately from either case that because x squared was subtracting the y squared, that this should open left and right. I also notice, because the x squared and the y squared are plane, that my center is at 0, 0 this time. Alright, so I look for my a. Again, find the x, look under it, and take the square root. So the square root of 4 is 2, a is 2. Under the y squared, I have the 16, so the square root of that is 4, making b 4. And then I can figure out my c by doing c squared equals 16 plus 4, those two numbers added together. So c squared is 20. C is the square root of 20, which ends up to be about 4.47, so I'm going to say 4.5 for our purposes. And then I'm going to come over and start graphing everything. Since the center is at 0, 0, this one will be a little bit easier to graph. I'm going to start with that, if it'll let me. And then I'm going to go left and right 2, because that's my A. So I'll be at 2, 0, and negative 2, 0. I'm going to go up and down 4, so 0, 4, and 0, negative 4. And then I'm going to draw my box that fits those dimensions. And will help guide where I'm putting my asymptotes. The next step is to draw in your asymptotes going corner to corner and through the center as straightly as you can, or as straight as possible. Don't think straightly is a word. Go the other way. And that is definitely not straight, but you get the point. And then once you have all that in, it's when you go back and you start thinking which way it's supposed to face. We said this one was supposed to face left and right. So you'll start the vertex on the corner of your, or on the side of your box at the 2 and go toward your asymptotes. So this one will be pretty wide. And you'll do the same thing on the other side. And there's your hyperbola. This time, when I go to put in my focus points, because this opens left and right, I'll count left and right. So I'm going to try to put them at about 4.5. So there's one focus point. There's the other focus point. You could also be asked about the slope of the asymptotes. And I did mention that on in some of the stuff above. If they ask you about the slope of the asymptotes, again, it would be positive and negative b over a. So in our case, it would be positive and negative 2. And if you count on your graph, it should be going up 2 over 1, up 2 over 1, or down 2 over 1, down 2 over 1. Those dotted lines should match that slope that we had talked about. Okay, so for our final example, we're going to do one that is definitely not in standard form, and we're going to need to complete the square. So following the same pattern as we did for ellipses, I'm going to write my x stuff together and my y stuff together, and you'll notice I don't have anything but a y squared, so I'm just going to put minus 3y squared. And I'm going to move the 16 to the other side by subtracting. So on the other side, it will be a negative 16. Okay, when there is a number in front of your x squared or your y squared, you do have to factor it out. So in this case, I'm going to factor out a 4. That will leave me with x squared plus 2x. Leave a space for you to complete the square. Over here, I do have the negative 3y squared. Now, if I had another y piece, I would need to factor that 3 out, but since there's not anything else with it, I can leave it like that and end up dividing it, and it will be fine. So, I'm at this point, and I need to complete the square with the x portion. So I look for the number in front of the plane x, which would be the 2 here. I'm going to take half of that number, square it, and add it to both sides. So half of 2 is 1. 1 squared is 1. I add 1 to both sides. But since this one was multiplied with 4, I need to multiply with 4. And then I'm going to go ahead and come up with this side over here. So I have negative 16 plus what ends up to be 4. And that gives me a negative 12. Over here, this will factor to x plus 1, x plus 1. So I'm going to write it as bring down the 4, x plus 1 squared. I'm just going to bring down the 3y squared. Okay, and then I'm to the point where I need to divide. I need this side to equal 1. This one's going to be a little strange, because if you're looking at it right now, you're thinking it's going to be left and right because it's an x squared minus a y squared. But because I have this negative 12 over here, and I'm going to have to divide by that, things are going to change. I have to divide everything by negative 12. Now, what happens there is over negative 12 becomes 1/3, and it's negative. So I have a negative x plus 1 squared over 3. On the next piece, I have two negatives which make a positive. 3 over 12 is 1/4, so I have y squared over 4. And then on the right side, negative 12 over negative 12 is positive 1, which is what we wanted in the first place. But you'll notice that now the x piece is negative and the y piece is positive. So in order to be in standard form, I'm going to have to switch those two things and write y squared over 4 minus x plus 1 squared over 3 equals 1. Okay, now that we are back in standard form, we can answer the questions. The first thing that I want to do is locate the center. And again, make sure you look not at what comes first and what comes second, but where the x and the y are. So the x will be negative 1, the y will be 0. Because this is a y squared minus x squared, I know this is going to be an up and down, so I'm just going to make myself a little note of that over here on the side. And that's for my personal knowledge. You don't have to do that. Alright, I'm going to find A, B, and C. So A will be under the x. Now, this is the first time we've run across this, but you are still taking the square root of that number. So A is going to be the square root of 3, which is about 1.7. Okay, the B you will find by taking the square root of the number under the y. So square root of 4 is 2, not a problem. Then C squared will be 4 plus 3, which is 7, and C will be the square root of 7, which is almost 2.6. It is helpful to go ahead and get those into decimals because if you're graphing, you want to know kind of where that's going to fall. So I'm going to come over here. I'm going to mark my center at negative 1, 0. I'm going to make my box by going left and right about 1.7. And I'm going to go up and down 2. I'm then going to draw in my asymptotes going through the corners of my box. And once I get all that done, I'm ready to draw my curves. Again, because it's y squared minus x squared, my curves are up and down. So I'm going to actually touch on the middle of that box on the upper part and curve toward the asymptotes. So that vertex right there should be, in this case, 2 above our center. If I had to label that, that would be at negative 1, 2. To do the bottom one, it would be at negative 1, negative 2. And go close to those asymptotes. So they could ask you what those vertices are, and that's why I wanted to even point that out. The last thing to do is put your focus points in. Because our distance is 2.6, you should start at the center and go up and down 2.6 because this is an up and down hyperbola. Those are my focus points, and that's pretty much what I'm asking you to do. The other thing they could ask you about, again, is the slope of the dotted lines, the asymptotes that we drew in. And if they ask you about that slope, it is positive and negative b over a. So in our case, 2 over the square root of 3 would be the easier way to write it for me. So it's just another question that can be asked. And that concludes this lesson.